The journey alone will make colonizing Mars an unprecedented challenge, but the enormous risk. Who gets to go? Think you have what it takes to be a space pioneer? Get in line. There are people already training Mars. Require a special breed of people. With missions that could last more than 2 years, selecting those... Colonizing Mars will require a special breed of people. With missions that could last more than 2 years, selecting those with the right stuff to be planetary pioneers will be critical to the success. But the enormous risk keep the number of people.
One, we have ignition.
The cost of a launch in the billions of dollars and the tight quarters of the spacecraft keep the number of crew people to a bare minimum.
I believe that number is 4. It's the smallest you can send and divide the crew up into 2 groups and have no one alone. And it's the smallest number that you can send in which you have the 2 primary skills of the mission both multiply backed up.
A crew of that size would consist of 2 ace mechanics who can fix anything, and in doing so, save lives. With mission joining could last more than 2 field scientists, the intellectual payload to be planetary pioneers will be Mars colonist success.
So, in terminology, I want 2 Scotties and 2 Spocks.
The cost of a launch in the billions. Mars colonists will need more than just these vital skill sets. They also need to be mentally tough.
I believe that number is 4.
People think that astronauts are tough. They will just always obey commands and will operate according to psychological reactions.
That you can
You really
send
have to
in which you
understand
have
that.
the
That's
2
part of the
primary
selection
skills of the
process.
mission both multiply backed up.
A crew of that size would consist of 2 ace mechanics who can fix anything, and in doing so, save lives. Your claustrophobic joining could need 2 field scientists, the intellectual payload, planetary pioneers,
So, in terminology, I want 2 Scotties and 2 Spocks.
Mars colonists will need more than just these vital skill sets. They also need to be mentally tough.
In my case, I fell asleep.
People think that astronauts are tough. They will just always obey commands.
You're not the right person.
Operate according to psychological reactions.
Dealing with being the only life forms on an otherwise lifeless planet will be another major psychological challenge.
Out there in space, you truly are just removed from mankind. And, you know, the interactions we have in life with the colleagues, friends, family, you just sort of take them for granted down here. But up there, all of a sudden, it is isolation like I've never felt before. If you're not totally comfortable with yourself, you're going to have some very, very difficult times up there.
Mars colonists will need more than just these vital skill sets. They also need to be mentally tough.
4 months to meet a Mars mission. Everyone's doing great.
To train people for the extreme mission, the Mars Society has built 2 Mars analog research stations to practice simulating only life forms on an otherwise lifeless planet will be another major psychological crews consisting of as many as 6 people, mostly university scientists and NASA personnel, operate under many constraints that astronauts will on Mars.
You just sort of take them for granted down here, but up there, all of a sudden, it is isolation.
They don't go outside without wearing spacesuits. They live on Martian time, 37 minutes longer than an Earth day. Their communication with Mission Control in Denver is on a 20-minute delay to simulate the time it takes for a radio signal to go from Mars to Earth. Maybe most challenging, they must coexist in a habitat with minimal personal space.
By doing that, you find out what works on Mars and what doesn't, and what kind of skill mix, what character mix you need in the crew, what technologies are likely to be most useful to the crew, how to organize the crew, who should command the crew, how tight you can ration the water and still sustain morale while you're doing this kind of work. This is not like a lunar mission, which only lasts where you can get 3 test pilots and you can just suck up the fact that they don't really like each other for that duration of time and get along.
37 minutes long. Crews first go to the Desert Research Station, located outside Hanksville, Utah, to conduct short-term missions lasting 2 weeks. Maybe most challenging, they must coexist in a habitat with minimal During that time, they perform EVAs, extravehicular activities, such as collecting soil samples for geological study. After completing their desert work, the crews are ready to join longer missions, lasting up to 4 months, at the research station on Devon Island in the Canadian Arctic.
Devon Island is one of the key places that you can conduct Mars research because of its isolation. It's the largest uninhabited island in the world. There are no signs of life around, maybe.
Station/weather station EVA will be taking readings of the surrounding area.
After completing their desert work, in addition to conducting field research, scientists at both stations also study each other as part of what they call human factors.
The factors research looks at the interactions between humans and computers, the interactions between humans and their environment, and with each other. By learning how we're going to react with each other in different situations, we can then learn how a crew will react together on the way to Mars or on the surface of Mars.
A lot of our findings sound very obvious, but they have not really been paid attention to before. For example, the very first thing you learn is that this activity, a field exploration while wearing a spacesuit, is a physical activity. The amount of exploration is very much contingent upon your physical fitness.
Station/weather station EVA.
It's saying you don't want to go to Mars
will be
with zero
taking
gravity
readings
if
of
you
the
want to
surrounding
actually get
area.
anything done, because we'd be deconditioned.
In addition to conducting field research, scientists at both stations also study each other as part of what they call human factors. It's a drop in the bucket.
Factors research looks at the interactions between humans and computers, the interactions between humans and their environment, and with each other. By learning how we're going to react with each other in different situations, we can then learn how a crew will react together on the way to Mars or on the surface of Mars.
Sponge baths every other day instead of showers every day. A lot of our findings sound very obvious, but they have not really been paid attention to before. For example, the very first thing you learn is that this activity, a field exploration while wearing a spacesuit, is a physical activity. The amount of exploration is very much contingent upon your physical fitness.
Station/weather station EVA.
You don't want to go to Mars with zero gravity.
In addition to conducting field research, scientists at both stations also study each other as part of what they call human factors. It's a drop in the bucket.
Factors research.
The year is 2040. The destination? Mars. After decades of careful study and research, the first human explorers are on their way to the Red Planet. After completing the 6-month journey from Earth, the longest manned space trip in history, it's time to land on Mars. But where's the best place to touch down?
You want areas that are geologically diverse, where there's a lot of different things to explore within a reasonably small radius of action. You want to definitely include areas that had water in them in the past, because that is where there could have been life on the surface. That's where you want to hunt for life. You want to go to places that are either in the temperate or tropical regions of the planet, because you don't want to go to a place where it's going to be dark for 12 months at a time.
By these criteria, the best place to land would be just north of the Valles Marineris, within driving range of runoff areas. Not far from where space probes Pathfinder and Viking 1 touched down. It's also the best place to establish a base camp that will function much like one in the wilderness on Earth.
Here in a remote wilderness area, we can establish a base camp because we have everything we need. We also rely on the environment. We get oxygen from the environment. We get water. We get wood for fire from the environment. Well, now let's imagine colonizing Mars. On Mars, we also rely on the environment. Colonizing Mars is going to require using the oxygen from the Mars atmosphere that we could derive from the carbon dioxide, growing food on Mars, getting water from the atmosphere on Mars. The same mix of resources from the environment and material that we brought with us is what's required to allow us to successfully colonize space.
Once the base has been established, the primary objective of early missions is to search for evidence of life in the past and the present. Using radar, astronauts attempt to locate groundwater within a few hundred yards of the surface, then bring it up with drilling rigs. Samples will be studied under microscopes in the crew habitat to see if they contain evidence of life. If the planet proves capable of supporting life, then it would be viable for astronauts to construct greenhouses and cultivate crops using Martian water, soil, and sunlight. As they search for life, these pioneering astronauts will have to contend with the one force that could bring the lofty ambition to colonize Mars back down to Earth. That's gravity.
The gravity on Mars is 1/3 the gravity on Earth. We don't know if that's enough gravity to allow for healthy bones and muscles. If Mars gravity is not suitable for human long-term survival, then it may become a place we visit. We may go there for a week or so. It's a tourist attraction, but it's not a home. And so that's a fundamental question that needs to be answered. Is 1/3 gravity enough gravity for us to live biologically fit lives? My guess is the answer is yes, but we have no direct data, so we can only guess.
Getting direct data will be vitally important. So will communicating it to Earth. The lag time in radio communication between the Mars crew and mission control, as much as 40 minutes depending on planetary alignments, will affect how the astronauts conduct their research.
It certainly means that the Mars crew is going to have to be a lot more autonomous than you could have with human crews in Earth orbit around the moon. You're not going to be talking to the Mars crew, okay, now step 2 steps to the left and head towards the rock. They are going to have to make their own decisions, and I think more generally the Mars mission is going to have to be led from the front, and that the commander of the Mars mission will be in the Mars mission, and rather than have mission control, we will have mission support on Earth.
Back to work now. Back to work, all you guys.
The habitat that will house the astronauts offers a preview of structures that could form the first settlement on Mars. As proposed in the Mars Society's direct plan, the initial habitat will be the crew vehicle itself. The tuna can, as its proponents call it, is about 20 feet tall and 27 feet in diameter. It has 2 decks, the upper level for cabins and a common area, the lower one for lab and workspace.
We have found in our field work that while these are tighter quarters than most Americans are used to living in, they're not that bad. You don't really feel that crowded. We tend to keep the private bunks very small so that we can maximize the public space, the wardroom where people hang out. If you've got a healthy crew where the people want to associate with each other, then this is clearly the best way to ration the available space.
As more pioneers settle on Mars, it may be safer to move the growing community underground.
Because it's a terribly dangerous place. There are sandstorms that can hit and knock over any surface establishment. There's horrible ultraviolet cosmic rays effects. You're going to want to save people's lives, save their reproductive abilities. You're going to want to have a place where you can raise children. You're not going to do that at the Martian surface. You're going to be doing that underground. Under those circumstances, it would be more like vast urban malls. probably very nicely lit. Nuclear and solar power, it shouldn't be a terrible life, providing that they get to a tipping point in technology, a tipping point in support from the outside world.
Early missions to Mars, if conducted during optimal planetary alignment, will last approximately 2.5 years. That includes the 6 months to get there, a 1.5-year stay on the surface, and the 6-month return trip to Earth. During that time, we will know whether Mars can support life. If it can, that opens the door to the ultimate form of colonization. Terraforming the planet to make it more like the Earth. Once humans establish a self-sufficient base on Mars, the next major advance in space colonization, say advocates, will be to terraform the planet, a process that will make Mars Earth-like. Wherever humans have settled, they've remade the environment to suit their needs. Mars cannot be any different.
Terraforming is perhaps the ultimate way to create a new Garden of Eden in outer space. And how would we do it? Take a look at Mars. Mars is a frozen desert. First, we would have to raise the temperature.
We know how to warm up planets. We're doing it right here on Earth, where it's not a good thing. Whereas on Mars, it would be a good thing. So in fact, we could do the same things we're doing on Earth, putting in the atmosphere greenhouse gases, which would cause the planet to warm. On Earth, that would be pollution. On Mars, it's medicine.
Calculations have shown that the amount of greenhouse gases that we need to introduce to Mars are reasonable. They're not really way beyond what we can imagine to produce. But the amount is also too large for us to bring it from the Earth to Mars. That means that those gases have to be produced on Mars. We would need to set up factories to produce those gases and then release them into the environment.
These factories would combine elements taken from the Martian environment, convert them to non-toxic fluorocarbon gases, and vent them into the atmosphere. Experts estimate in about 100 years, these greenhouse gases will have terraformed a cold, dry, dead planet into a warm, wet, life-supporting world.
It's interesting to think about what would Mars look like after 100 years of warming. It would be bluer than Earth. You'd see large patches of water. You start seeing little fringes of green around the margins of these blue areas. And then with time, this infestation of green would move away and up and into the mountains. And eventually, you'd see a world of blue and green with little islands of red that remain, almost like national parks preserved.
Even in the first stages of terraforming, the temperature will rise and also the atmospheric pressure will rise. That will mean that humans will actually be able to go out just in suits that really press down on their skin in order to recreate some pressure and with an air mask. And that would really make it much easier to go outside. It would probably take quite a while for Mars to become really a place like this, where we're in a greenhouse at the Los Angeles Arboretum. It would definitely take a while before we have such a paradise as this. But we can start from very basic algae, mosses, maybe grasses.
While this is going on, genetic engineering of the people themselves could also be taking place, so that you are breeding in, either through selection of your offspring or possibly even genetic manipulation, generations of citizens who need less gear when they go out on the Martian surface. Their skin is less fragile to the ultraviolet, to the low-density atmosphere. And eventually, they just need their respirators less and less. As the atmosphere increases, so does their ability to meet the atmosphere halfway. And these would be the beginnings of the true Martians, the people who could actually make this world their own.
NASA itself is not interested in terraforming planets, partly because it sounds very science fiction-y, but partly because there are real ethical questions involved. You will find a lot of people who believe that human beings should not go into space because we will just destroy things in the way that we've destroyed our own planet, and that we need to preserve the Moon and Mars and the other planets the way they are for scientific investigation.
Whether we should terraform Mars is an issue for future generations to resolve. It's a very distant point on a space colonization timeline that could begin with this generation.
The one thing that we can probably predict is that we will see ourselves in other places of the solar system than the planet Earth. Space colonization will be driven by the normal processes that we've seen over human history of expansion of people from one place to another across frontiers. Space is another kind of frontier. It's a technologically challenging frontier, but the human species has been extraordinarily resourceful over its history in its ability to adapt and to overcome challenges like the frontier of space.
My son, maybe someday he'll follow in Dad's footsteps. And I would be awful proud knowing that you blazed the trail. And, you know, he can do it. You know, next generation, who knows where they'll be.
Space colonization will be the ultimate camping trip. It'll test our equipment, it'll test our planning, it'll test us. But it'll be worth it. We'll learn a lot about space, about our own Earth, and about ourselves.
Whether it happens on Mars or somewhere else, maybe even beyond our solar system, space colonization won't be driven by the desire to plant a flag, but rather a seed. In the future, when we gaze into the heavens and ask, "Is anybody out there?" the answer just might be, yes, it's us.
In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence